All right. Good afternoon, good morning, everyone. So we're gonna get started this second webinar on how to scale up distribution grid inspection using Sterblue software. Uh, so let's get started with the panelists. So we have Nicolas Draber, which is our Chief Product Officer at Sterblue and also co-founder. We have Samia Belasri, which is Senior Account Executive, especially for the EMEA area, and myself, Jeffrey Van Kessel, CEO and co-founder at Sterblue. And we also have in the backend Teresa, which have organized this webinar. So thank you to her, and also Vincent Lecuyer, our Chief Technology Officer, which could answer the highest technical question you may have at the end of this webinar. So let's get things started with the program, the summary. So the agenda is a glimpse of Sterblue. Just for those who don't know Sterblue, just a quick word on the company, his story, and our mission, the market evolution, the tech trends, especially in the distribution grid side. Then we'll go to the platform, demonstrating the different multiple use case that we can tackle with. So Samir will go through it. And finally, we'll go through two different business cases and demo with Nicolas. So two business cases will be specifically vegetation encroachment and detailed technical inspection. And in the end, there will be a Q&A session where we'll be happy to discuss with all of you. So Sterblue was created in 2016. We now have offices in France, in Nantes, in west of France, in Portugal, in Lisbon, and in the US to support our North American customers. Our mission is to build the integrated platform for infrastructure inspections. So today we mainly work on 4 different applications. So wind turbine, transmission and distribution grid, and cooling towers. And we are backed by top investors, Y Combinator, and some energy investors as well, such as EDP Ventures, Future Energy Ventures, C Ventures, and also the Rester Group, an institutional energy fund. One word on the customers. So Sterblue has now more than 40 different customers, energy customers, in 19 different countries, so on almost every continent. And so far we have inspected a bit more than 5,000 kilometers of power lines. And yeah, just to give you the high level workflow on how it works. So we usually start gathering some clean data coming from different sources, especially for the distribution grid side. So coming from satellite, smartphone, helicopter, drones. Then we have a step where we manage your data. It means that once you have collected data from multiple formats, multiple sources, and you have like thousands of it, we support you managing this, sorting them, making sure you just keep the most relevant ones for your analysis and ensuring your grid resiliency. Analyze your data. This is a step where our software supports you having the most streamlined process, analyzing the different defects on your infrastructure with a dedicated artificial intelligence to save time here and increase reliability. And finally, monitor asset health. So we have different dashboards and capabilities to aggregate process data and make sure that you have exactly the information you need to run your repair maintenance campaign, for example. Market evolution and tech trends. Just one slide that could summarize actually what we see in the market for the last 5 years. So if we go back like in 2012, 2015, that was the arrival of drones on the market, and many players all over the world were testing. So it means most of the utility companies actually were manufacturing their own drones just to give a test, and it was mostly used to capture images at a higher altitude, but nothing really more what was done back in this time. And a couple of years later, actually, what we've seen on the market is that uh, most of the big players were struggling with data management and analysis. We've heard so many stories like, hey, we've captured like 10,000 pictures. but it is on a local drive in some folders. We don't know what to do with it. We don't know how to analyze it, etc. We even heard some people telling us, hey, between each distribution pole, we have to take a picture from the sky to differentiate one pole to another. So data management and data analysis is where the market struggled for the last years, and this is also, of course, where we can support. And we see more and more now the large utility companies focusing way more on having some digitized workflows and focusing on the value, on what the data processing platform can bring to their workflow. And also we see more and more need of gathering different source of information. Drone is one source. Helicopters will keep being in the game for a long time, and because that's a useful mean to capture pictures as well. Smartphone is pretty important. You can see just a problem when you're on field. You can just go down your track and take a picture of a problematic pole, and satellite, of course, to manage vegetation. So all of this source of imagery needs some streamlining workflow just to merge all this information and just extract exactly what you need. And this is actually where the market is right now, and where it is going for the next years, actually having a centralized and integrated approach to deal with multiple sources of imagery on distribution grid. So different tech trends that support this market trend. So of course, artificial intelligence. I'm not it's not new to tell you that if you have like, let's say 1,000 kilometers to be inspected, so 600 miles, you're gonna have more than 25,000 pictures to be analyzed. So of course you can use some subject matter experts to perform this task. But today there are some proven dedicated AI that can support you in this hard task. For example, here, this is actually a Belgium picture for Belgium customer, and we have proven just that we could save up to 21% of their labeling time without any prior training using Sterblue AI. The second tech trend is actually process digitization and modularity. Having worked with 40 plus different customers, we figured out that modularity is key. All these large players have some different workflows, different needs. One is going to be more interested into sorting imagery in a smart way. The other is going to be more interested just in the AI. The other one is just building faster some reports, etc. So we need some flexibility if we want to be fully integrated within these large companies. And this is what we're actually building with a framework that we call Superblocks at Sterblue that allows us actually gathering user interface in an easier way to meet the exact right customer workflow, and that makes things way easier to get things digitized actually. Another tech trend is, of course, the ecosystem openness. Today, no one can claim doing everything, and at Sterblue, I mean, we claim being really good at centralizing this imagery, this different type of imagery, to support the inspection process, the asset monitoring process. But we have also the capability to be connected with the rest of the world, with your IT ecosystem. A concrete example of this is, we are connected with Zapier. Zapier is an app that connects apps together. So for example, if you collect a picture with your smartphone, I have in my hand, and for example, there is a broken distribution pole in the road. So maybe that's a high level alert, a high criticality alert. So you would like your colleague in the office to receive a text message. That's actually what Zapier could allow you to do. Just connect app together. And that's pretty important. We have an API as well to make sure you can query anything you want on the platform to feed other systems like Esri, SAP, Maximo, etc. And another tech trend is, of course, the digital twin and asset modeling. That's extremely important to have an up-to-date and enriched geographical information system, a GIS system. And this is where we want to help, making sure that there is a sync between the real world and the digital twin that you have in your system. And this is, for example, something we can do with modeling precisely different type of poles based on the lidar data that we have, on some information that you gave us, and make sure that there is an important synchronization between the real and digital world in the end. Samir, you want to take the lead here?
I'll share my screen to continue the presentation here. So yes.
So just stop sharing. So it should be okay on your side.
So yeah, you can see my screen.
No.
Sorry. All good now?
All good, yeah.
Perfect. So yes. So to continue on what Jeffrey said. So what we believe at Sterblue is what the industry needs today is one platform to manage your multiple asset inspection use cases. So from where this multiplicity is coming from. So today, to have a full vision of your asset integrity and manage the inspections and the maintenance, you will need several data sources. So as Jeffrey said, you will need satellite pictures, drone pictures, helicopter pictures, maybe pictures of some other kind of sensors like infrared. So once actually all these data sources, this platform needs to store them in one standard model, which you can understand and use. So the second factor of multiplicity will be that this data will need to be used by several user profiles. So the needs of these profiles may vary depending on their specific company. So the need of a utility company in Turkey or in Australia may not be the same, and also on their level in the hierarchy or their position in the company. So this is actually requires from this one platform to be able to provide several interfaces adapted to every usage. So the third level, the third source of complexity will be that this platform, as Jeffrey said, can't be isolated. It needs to be able to communicate with several third-party systems that you already use. So systems that will need that are actually needed to plan the maintenance, systems that you use to produce some kind of business intelligence dashboards, etc. So for that, this platform needs to have some interfacing capabilities, allowing the platform to connect with the IT landscape that you have in place in your organization. So a few use cases that we have identified within companies, utility companies, so distribution companies who have been working for. So obviously there are other use cases we may not face yet, but you will tell us about it at the end of this webinar, I guess. So a few words about this use cases. So the first use case is helicopter inspections. So some of our clients operate in very large areas with a lot of remote locations. So it's not realistic, for example, for this kind of clients to be sending a pilot with a drone and with a car to these remote areas, for example, in the Australian desert. So they may be using helicopter inspections. So the Sterblue data platform is able to manage this kind of data and provide inspection results. Some of our clients have teams that are qualified to do ground inspections. So we provide them a tool allowing them through a mobile device to collect the data and process it through the Sterblue data platform. So then another topics we have been talking about a standard way to store the data. So a topic which is coming, which is progressing a lot in this industry today is predictive analysis. Predictive analysis requires data which is stored in a standard model with a certain anteriority. So using the Sterblue data platform allows you to have this data stored in this one standard model and have the history allowing to have some prediction in terms of inspection and maintenance. Another case we can talk about is vegetation management. So today, utility companies and specifically distribution companies have contractors that actually they hire to do tree trimming. So for that, they will need to have a full visibility of vegetation encroachment risks. So Sterblue platform allows using satellite pictures to have this inclusive vision and plan in an optimal way the tree trimming. One last use case we can talk about is emergency inspections. So after actually a storm after a storm is after a storm actually passes on a specific area, utility companies and specifically distribution companies need to have some efficient manner to witness any fault triggering service interruption and be able to react. So we have a live inspection tool allowing to perform this kind of inspections and provide all this information to react fast. So maybe before continuing, we'll ask you a question to get to know you better. So what kind of use cases among the list that you see here is the most impactful for you, or you would like to change the most?
So you have a poll which
You have a
has
poll
been
actually.
displayed, so you can just click on what interests you.
Yes, you can choose as many options as you think are relevant.
Yes.
Okay, we have 1/3 of the people which have answered.
Yeah.
It's growing fast.
Okay,
Okay.
couple of more seconds. I think there are people still answering. And I think it's good. I will end the poll.
Okay, perfect. So yeah, so the results of the poll. So I can see actually that that's actually the most interesting use case for yourselves is detailed inspection. So it's 30% of the votes. So remember that you get that actually the voters can answer, so can give several answers at the same time. So vegetation management 56% and inventory management comes third, 36%. So we have been lucky, but maybe not that lucky, because I mean the first two use cases will be treated in detail in this webinar. And for the other use cases, don't hesitate to ask us questions and at the end of this webinar, so we can actually provide you answers. So yeah, so during this webinar, we will be actually showing you in details how 3 use cases are managed using the Sterblue platform. So the first use case is detailed inspection. So for this detailed inspection, what actually our clients need is to have a full visibility and the detailed information about asset integrity. So it allows, for example, to have a long-term maintenance plans, allowing to extend the lifetime of assets and optimize the maintenance plan itself. So the second use case we will be talking about is inventory management. So aside of getting to know the defects and being able to build maintenance plans to fix them, a good information to have is also what kind of equipment is present on the grid. So this allows to plan to better plan the maintenance works themselves. So know what gear needs to be taken, what needs to be replaced, and also to have an inventory and the full vision of the assets. So the third use case we will be talking about here is vegetation management. So as said previously, the goal of this use case is using satellite pictures. So without needing to deploy any operations on the field, collecting some kind of data like LiDAR data, just using satellite pictures, being able to have a full assessment of vegetation encroachment risks and what are the priorities in terms of tree cutting, of tree trimming. So yeah, so these 3 use cases sound quite straightforward, and it looks like it can be addressed in one standard workflow. But actually, the reality shows that every client is specific. So every client has actually various priorities. It has actually existing workflows that can be changed from 0 to 1 in 1 week. So actually, that's why at Sterblue, aside of having one unique platform to manage these use cases, we believe that we need actually to go to few steps to implement the Sterblue tool within your organization with minimal risk. So actually these steps, the 4 major steps will be to analyze, deploy, adjust, and then scale up the use of Sterblue platform. So the goal of the analyze step is to map your existing process, so get to understand what are the issues in this existing process, what are the pain points you would like to solve, and at the end define the target process, which obviously need to address all the pain points we have identified with you. So once actually this step is over, we have a good vision on where we want to end in terms of asset inspection workflows and from where we are coming. So at this point, Sterblue platform, as Jeffrey said, has configuration abilities in terms of interfaces, of user interfaces, and also connection to third-party systems using the API. So this is some configurations that we can do during this second phase. Then we deploy a pilot project on a limited number of assets. Once actually we completed this deploy phase, we have actually a feedback on the theoretical knowledge that we have gathered during the analyze phase. So we can actually build the business case and show you, according to your criteria, what's the return on investment of implementing the Sterblue as a central data platform. So from this business case, we can adjust the inspection workflow, and we can build with you a change management plan, which actually we can advise you on based on all the experience we had with several utilities around the world. And then we can scale up the Sterblue central data platform to make it the central data platform for all the infrastructure inspections. So what's the value? What's the added value you can expect from using Sterblue as the integrated data platform for infrastructure inspection? So the first added value is being able to manage several multi-source high-resolution pictures on one unique platform. So you could on the same platform do technical inspections. So actually get to see all the defects that are present on your distribution poles, for instance, and also manage, for instance, the vegetation risks. So this being said, Sterblue also has a solution to collect this data in a standard manner using drones. So for this, Sterblue has a flight app and the flight methodology, which allows you to have pictures in a standard manner. So once this picture collected, you end up with a large amount of data. So here actually the issue comes to how to analyze all this data. So as Jeffrey said, we have an artificial intelligence model which is able to automate the detection of your specific defect as per your referential. And the experience with clients proves that 30% of expertise time can be saved using this artificial intelligence. So once the analysis done, depending on the user profiles that are using the platform, several inspection reports may be needed. For example, the maintenance team who go on the field to fix the defects will need detailed inspection reports with the pictures of every single defect and a list of the equipment present on the pole. So for this kind of users, there is actually a detailed PDF report and also a CSV format of this report. Asset managers may need some high-level vision of asset integrity. So they may require a consolidated vision through some key performance indicators that we build. So Sterblue platform offers also configurable dashboards to be able to have this vision. So the fifth point here is that asset inspection may involve several actors. So the first actor can be operation and maintenance companies who are actually doing the inspections by themselves, but are also consuming the inspection data to perform the maintenance. There may be asset managers, and then management, and maybe then other third-party service providers. So the Sterblue platform can be used by all these actors and gather them on one unique vision of asset integrity, giving this 360 degrees view. The last point here is that several clients we have actually one issue they couldn't anticipate, is that they have several service providers who are providing services in inspections and maintenance, and they provide them only final report, keeping all the source data of asset integrity on their side. So having a platform like Sterblue, which is shared between your service providers and yourselves, allows you to have full control of the data. So you're able to follow up all the data flow from its collection by the inspection service provider till actually the end of this data life cycle, when a specific defect is fixed and tracked on the Sterblue data platform. So yeah, so how you can how you can start working with us. So the Sterblue based business model is enterprise SaaS. So we can provide you Sterblue as a SaaS platform that you can use autonomously to perform all the inspection tasks and follow up all the inspection process end to end. So the model is you pay per structure. So there are no upfront fees. You pay actually you pay as you use, and you are free to stop at any point of time if you need to. So the second model is the full scope inspection. So we have the resources to use actually our own data platform to deliver you all the inspection service end to end, meaning we have pilots to collect the data of the infrastructures. We have actually artificial intelligence and industry experts able to process this data and produce the reports to deliver you the final inspection results. And we can produce obviously dashboards giving you the full vision of asset integrity. Then actually, as every case is specific, every client case is specific, there are hybrid models. Some clients would like, for instance, to train their internal inspection experts to be able to process all inspection data, but they are not willing to train drone pilots to do the flights by themselves, in which case we can provide all the resources to collect the data using drones and train into our clients' internal inspection experts to process all the data on our labeling interface. So maybe another question. So what is your biggest pain in distribution grid inspections?
Yes, just to clarify this point, so maybe capturing data and managing large missions,
Yeah.
ensuring training consistency.
Maybe sorting,
pilots.
yeah. So sorting millions of images, accessing inspection data from different repositories, ensuring defect detection exhaustivity, aggregating information in specific business dashboards, or building custom inspection reports. So you, as for the previous question, you may actually have multiple answers if you like to.
It's a long question, so we leave a bit more time.
Yeah, there are many choices here.
We are almost at 60% voters.
Also, if you have any question about the options, you can ask.
Yeah.
Okay, I think I will close the poll now. Okay, still some people voting. One last second. I will close it.
Okay, so the most common challenge is capturing data and managing large missions. So yeah, so this is matches perfectly the first the first use case, which we will be demonstrating in the next part of this webinar. Ensuring defect detection exhaustivity. So this is actually what Nicolas also will be showing through artificial intelligence automated detection. So don't hesitate to ask us questions. And sorting millions of images. This is also will be a part of the demo, because as you will see, once you collect all the data and you upload it on the data platform, all the sorting and the storage of the images is done automatically. Maybe another important point is building custom inspection reports. Yeah, so Nicolas will show the flexibility that Sterblue inspection reports can have. Yes. Still moving this. So the first business case is with one of our main clients. So it's a national French DSO. So you can see we inspected with this client more than 3,000 kilometers of lines in 12 regions in France. So you can see on the right side of this slide all the distribution, all the locations of the distribution lines we have inspected all over France. We deployed with this client 4 business cases. So asset life extension detailed inspections. So this client needs every certain amount of years to cover all the grid with these detailed inspections to be able to build long-term maintenance plans for life extension. So this is what this use case is about. Emergency inspections, meaning an app allowing to fast reaction after a storm when actually there is any service interruption, vegetation encroachment, we have been talking about previously in this presentation extensively, and inventory management. So yeah, so the second use case Nicolas will be showing today is with the National Belgian DSO, where we have been working with in 2020. So actually, we deployed also with this DSO both visual inspections and vegetation encroachment risk assessment. So after actually this first project we have done, so all yearly asset inspections are done now using the Sterblue platform. So all the visual inspections and including also vegetation. So one very interesting output we had through this project is that we measured before any round of training on the specific referential of this DSO, the defect features of this DSO, that artificial intelligence with our pre-trained model allowed to save 20.1% of time of analysis of inspection data. Then actually one other very important output is that we actually reached the lean integration of satellite and drone pictures, meaning that all the risks that have been identified using satellite pictures could be linked and related to visual inspection pictures that we have collected using drones. And thanks to this project, now we have a network of local Belgian drone pilots who are ready to be deployed and for drone inspection for any clients in Belgium.
Hi everyone. Let's have a look at distribution grid detailed inspection. So what you see here is the Sterblue interface, and more specifically the maps. All the assets are visible on the map. So here I've selected one, which is located in France. We can zoom in, and what you want is to perform a detailed inspection of this grid. What you can see is that we are displaying the axis, and on top of it, where available, we're also displaying the LiDAR, which gives great information about the location and the environment just around the lines. So let's imagine that this line has been inspected and you want to review the defects which were detected on this portion of the line. So let's go back to the home page, have a look let's have a look at all the mission lists which have been performed, and let's type the name of the line to look for the results. So here's our line. I'm selecting it. I have an overview of what has been detected. So by the color code, you can imagine that some severe defects were detected. It's also telling me how many assets are part of this inspection and how many images were captured. Let's select it. So here's a recap of the progress of the different information gathered in this during this inspection. And here we see the process through which the mission is going. So first, let's select operation. That's where the pilots will be able to drag and drop their images. Okay, so nothing complicated. They can simply drop the content of their SD card, and all the pilots can drop images. Doesn't matter. Selection, the next step, allows you to review the images which were captured, and they are automatically linked to the different poles of the line. So, and they are grouped together. So here we see all the images which belong to the pole 136, pole 137, etc., etc. Yeah? And there are two lines because the experts are able to say if they want to reject some of the images because they are poor quality or because they are duplicates. Often pilots are taking two pictures when they are unsure if the drone actually captured one. So, and this is what you see here. Those two are almost similar, so there's no need for the AI or the expert to look at it twice. Once the pilots or the experts have once the experts have reviewed those images, what they do is they go on the image list, and they can start having a look at what the AI did and correcting the detections or adding detections if necessary. So we can simply select one image, and we can review what the AI did. So here we can see that some of the equipments have been detected, installator for instance, and some defects also have been labeled. So here we can see, okay, shackle is one shackle. And we can go having a look at every images to see what is the detection, what detections were made. Once this is done, well, we can have an overview of the list of detections, clicking simply on the detections tab, and we can scroll through and have an understanding of all the different detections. Because there are so many, what we'll do is we'll simply generate the reports, which will allow us to filter then the anomalies and only displays the ones which are relevant. Let's have a look. So we'll generate the report, and the report will appear. The last step will be available. So I validate the anomalies, and I can now select the report. So it will take a few seconds to appear, and here it is. We are able to have a PDF of all PDF report summarizing the different anomalies which are found during this inspection. So we have a timeline which summarizes when the inspection was ordered, when the report was generated, number of anomalies. We can have then overview of the different poles which have been inspected, and we can then go through the different anomalies and click, for instance, here. Okay, so we see that here some anomalies have been detected, etc., etc. So the report exists in different flavors. There is, of course, the PDF, and we're also introducing new formats, which gives you like a better overview. So let's have a look. So we can select PDF, but on top of it, we are now introducing also tables, which gives an easy way to overview the situation. Those tables will be also customizable, so if you need extra columns or specific fields, just let us know. We have the pivot table, which also are great to quickly understand the situation. So here we see the different poles, the different type of defects, and how many have been detected per pole. And we have also graph charts that we're introducing, and we'll be able to display different types of graphs. So each entity can have its own graph, and we can easily customize those graphs based on your needs. So don't hesitate also to let us know what you need to see and what graphs you like. We'll give you some presets, but we are very flexible and we'll be happy to customize them so that it meets your needs. Thank you.
So we had some question. I'm sorry. Why don't we have? Yeah. Okay. So, are you experienced in the inspection of distribution overhead lines in urban sites? Nico, if you want to give a word on this part.
Yes. Excuse me. Switch back to here. So sorry, experience on
urban lines.
Urban lines, yeah. Yes. So urban lines, in fact, the only changes are on the regulation side. Depending on the country, it may be more or less difficult. To give you some examples, often what is required is that the drone fly not as far as what we can do outside of cities, but otherwise it's the same. So it's only a matter of logistics. It changes nothing in terms of product.
All right. Can we use Sterblue from Africa? Yes, and this is actually pretty well used over there. We've been working, for example, for the last 3 years in Ivory Coast, where we have a large utility customer over there, and we have inspected, I think it's more than 600 transmission tires and a bit more than 2,000 kilometers of distribution grid. So yeah, pretty. This is available. We have also some experience in South Africa. So yeah, happy to discuss this topic afterwards. Feel free to reach out to us. Can I receive the presentation? Yes, of course. With this product problem, we'll make sure to share with you a more exhaustive demonstration, of course. What was the voltage level? The lines was in agriculturing area. What was the volume of the projects? Please give me estimation of price of a lot of projects. So not sure I got everything, but the voltage is, it depends the countries for distribution grid. but it's usually from 0 to 20,000 volts. The line was in agricultural area. It depends. The lines we inspect or the lines that our customer inspect can be in urban area or some rural areas sometimes. So there is no rule here. Of course, everywhere where there are people, there is electricity. So it really depends the projects and the volume of the project in terms of kilometer inspected. It depends as well. Some of our customer just use us for a couple of kilometers, a couple of miles, and some other just inspect thousands of kilometers. So that's heavily variable, I would say. And for the price, please reach out to us. We'll be happy to discuss your project and see how we can support you, for sure. Can you more explain Sterblue business model about costs? And someone asking this, which work or owns a national electricity company. Yeah, sure. So in short, Sterblue business model is to deploy your teams using Sterblue software. So it means you have some pilots, you have some expert, and you just want to make sure that your process is digitized and you have an integrated and central platform to perform your inspections. So that's the first option where you are, I would say, strategically independent. And the second option is that this is not a top priority to insource, internalize such a software. So in this case, you just tell us to inspect a segment of the line, and we perform a full scope service inspection. So we handle everything for you. But again, happy to discuss more in detail this point afterwards with you. How much time to make 1 kilometer of distribution line, Nico? Want to take this one?
Yes. So again, it depends on what you want to detect. If it's detailed inspection, 1 kilometer will take more or less 30 minutes. So that's one battery. We take as an average that there are 10 poles per kilometer. So that's what a pilot would do, about 30 minutes for the capture part.
Another one for you, Nico. Those GIS pole line locations needs to be extremely accurate to use satellite imagery for vegetation management encroachment effectively. And another line connected, can satellite imagery to be used to true up GIS pole line locations?
Okay, so yes and no. Of course, if you have very precise pole location, then we are able to output precise distances to your assets. But some customers do not have LiDAR precise assets, or so what we do is we output the vegetation in a wide corridor around the axis, or where the axis is saved in the GIS, and then this allows to bring some alerts and then only go there to assess if the line is effectively close to the vegetation. And can we use the satellites to more precisely position the assets? Again, yes and no. So we have some customers for which their GIS are sometimes as far as 50 or 100 meters away to the actual poles. And in this case, yes, because satellite images can be as precise as a meter or less. But yeah, so it depends what the customer has is its GIS.
It depends where you start from, but in short, yeah, it's having a meter resolution to get a good vegetation encroachment management is good, and it is also the resolution you can relocate your infrastructure, generally speaking. Another question, does Sterblue have a French version? Actually, Nico, Vincent, myself, we are French. So we started the project in French. Now we have it in Chinese, Russian, English, etc. So
Portuguese and Spanish, yeah.
So absolutely, this is available in French. How can we interpret the report after your AI analysis? So here there are two models to work in combination with the AI. The first way is that rerun the AI on a set of defects where the algorithm is good at detecting it, and you have some resources on your side to double check and to make a quality check and validate or invalidate what the AI has detected. Or the second manner to work with AI It's just that we do it internally at Sterblue. So it means we have some partners which are distribution grid experts, and they are going to review your pictures to make sure you have something consistent in the end. So there are two ways. Either you use the AI with your own experts just to validate or invalidate detection and you generate the reports, or we do it, we do everything, and you just have the a comprehensive and exhaustive final report. We are a team of drone pilots and have connections with DSO. Do you have exclusive partnerships? Yeah, we have some partnership in many different countries. Of course, we need to assess this business relationship, but happy to discuss after this webinar, of course, about a potential relationship for sure. Sorry, somebody is looking at the picture and finds the anomalies. So, yeah, there's a question about if the drone, I guess this is it, if the drone finds the anomalies on its own, or someone is looking at the pictures and find the anomalies. Really good question. So Nico, you want to take this one just to split with the live inspection and the post processing?
Yes, exactly. So in fact, we didn't mention it during this webinar. It will be a webinar for its own, but in the live inspection, so which is more used for emergency after storms or things like this, there is a, I would say, live detection of major defects. But otherwise, for detailed inspection, the detection of equipment and defects is done on the cloud by the AI. So it's not live. So yeah, it's just to distinguish the two types of inspection.
We have a question again for you, I guess, Nico. How do you compare the vegetation assessment by satellite and by drone or helicopter in terms of accuracy, for example?
Yeah. So too bad that was part of my demo, but we'll share a video of this. So in the demo, I was presenting for a customer where we perform both vegetation analysis with satellite and drone flights. And so basically the drone pictures allow to assess the alerts and the severity. Because satellite images are 2D, coupling this with drone images allows to better visualize if it's a real threat or if it's a false alert, false positives.
Okay, thank you. So we have Andrew from a large utility company that proposes to participate to a tender. Yeah, of course, we'll reach out to you after this to discuss, and we'll be happy to support you here. What are the type of drones that work with Sterblue platform? Can you give a warn, Nico, especially on the distribution side, of course?
Yes, so basically, to make it simple, any type, as long as you have some GPS coordinates which are saved within the pictures. This will give you, like, I would say, most of the Sterblue platform features. In case you are using DJI, we're able to extract some extra features inside the metadata of the images. So precisely what was the drone looking at, what was the camera orientation, etc. So you would have some 3D features that you may not have with other drones. Let us know if you want to, if you're speaking about a specific model.
Okay, thank you. Is there a specific flight plan angle to take those 6 pictures? What would be the best gap between drone and the pole? Yeah, there is. We've built actually a standard procedure, and we'll be happy to share this with you after this this exchange. And there might be different procedures applicable depending on your asset policy management. And but yeah, we can give you the best practice. We have some documents here that support some training. So happy to discuss this point afterwards to make sure it fits to your customer or your asset policy management. We have a question on: do you capture the data you analyze, or can we provide the data from our prior inspections? Samir, you want to take this one?
Sorry, I was actually answering Andrew on the chat. So which question?
Okay. So do you capture the data you analyze, or can we provide the data from our prior inspections?
Yes, actually, this is a question which is often addressed with several with our clients. First of all, because it's clients often have legacy data that actually needs to be integrated on the platform also to gather the intelligence on the asset themselves. So yes, so we can actually use the data you collect, either legacy data or that you collect through other means on the Sterblue data platform, and provide the reports and all the outputs.
Thank you. Have you any experience of interfacing with SAP for generating work orders? Oops, sorry, the chat moved. Work orders following on from the AI assessment. So actually, we've been working with a couple of customers integrating Sterblue platform with SAP, especially outputting the right file format, and also we've been using our API to especially to connect with other software, not SAP yet. But let's talk about your project. We have a huge flexibility here, and that's of course the next step of the value chain. So we'll be happy to interact on this specific point. Okay. Do you have any other question? I think we're good.
Yeah, there was a question about the drone. So just to be very concrete, it was okay. Can we use DJI Phantom 4 Pro RTK? The drones that are regularly used for distribution inspections are the DJI Phantom 4 Pro RTK or the Mavic 2 Pro or the Anafi or even Skydio 2 would be very good drones. Basically, you want to take a small drone because you need to move regularly during your day, and big drones will provide better picture quality, but in terms of productivity, you will not be able to inspect a lot of miles or kilometers.
All right. Okay, I think we're good. There is no other question. Oh, does your AI detect transport lines or only distribution lines? So there is the last webinar of this webinar series, which is next week. We'll talk about transmission grid. Nonetheless, yeah, we have some capabilities to detect some defect on the distribution side and also some on the transmission side. On the transmission side, just to give you a little teaser, we've been working a lot on the corrosion, the rust detection, and especially the capacity to aggregate this information to build some specific health index status, because providing thousands of detections to an asset a condition monitoring manager is not useful. But if you start aggregating it according to specific rules, you can get the right output to plan the right maintenance and repair campaign. We have two other questions. Do you have any water drones for submarine cables too? No, maybe I should say not yet, but not for now. But thank you for this question, and that's a big topic, I guess, for offshore applications as well. Another question: along the transmission line, how will the drone be flying? Manually by pilot, or it's an autonomous flight? If autonomous, how will the drone know at what distance should it capture the visuals? What resolution do the captured pictures have? So first I'll do the answer on my side, and Nico, you can take the transmission grid. So on distribution grid, we our customer don't use that much automatic flight. But on transmission, Nico, you can give a word on the input data that we need, and also the accuracy of the flight while being performed.
Yes, so we need as much data as you have, I would say. So if you have LiDAR, for instance, it's more than enough, and then we're able to extract like the height of the pole, the width, and that's typically the data we need. Of course, the GPS coordinates too. Some customers don't have LiDAR, but they still have this in their GIS. So you can also simply share an Excel file, one line per tower, giving us the basic dimensions of your tower. And this will be enough also to perform an automatic flight. Regarding distances, again, we have a method of work. So we mentioned the 6 pictures for distribution. Then we also, after our years of experience, derive and wrote some detailed processes for transmission tower inspection. If it's automatic flight, you don't have to learn anything because the trajectory will be computed directly as best for the asset. If it's manual flight, then we give you some precise instruction. For instance, fly 10 meters with this angle to the line, etc.
And we close this webinar with the last question, which is how can we ensure the quality of your defect detections and classification models? So actually, when we roll out some automatic defect detection capabilities into production, we make sure that we've reached certain performance level, especially the precision and recall, which is the capability not to miss any defect and the capability to detect a certain percentage of defect within an image, within a scene. And we usually and this is also something that we test with real users to make sure we save time and that we reach the right exhaustivity in the defect detection. So we have a procedure in place to make sure that the performance are good and that the users, the experts, can rely on these detections. Oh, okay.
There are still some questions.
Yeah,
on the
sorry.
link.
Okay, really fast for the last ones. So do you have an APIs to integrate with other web platforms? The answer is yes, it is documented and we could share the link with you. That's pretty flexible here, so pretty cool. Do you have a comparison of benefits of using drones versus helicopters? Yeah, there are different benefits of using drones, which can be, having more precise images, of course, because you can fly closer, having more different angles around an infrastructure, because with helicopters you cannot navigate everywhere. Having a more, I would say, decentralized approach of the inspections. It means that helicopters are based in large business unit, I would say, all across an area, and drone can be more distributed with an easy way to deploy it across a territory. What else? Drone can be automated to have a standardized set of pictures, and you can just have a more standardized inspection program, and this is also the gateway to predictive maintenance. If you have the same data capture methodology here.
I would just add something, Geoffrey, is
Yeah,
that for some of our customers, we have a customer in Australia, drones is not an option. Everything is so remote. They have to fly there with helicopters. So our platform was built also to accept like a lot of sources of data. So we're able also to process helicopter images. We know that helicopter will remain if they are very productive. They take some great pictures. So in some specific use cases, we will be having helicopter images, and those same images are processed on the platform.
Absolutely, and we don't oppose these two means of inspection, just because some have more benefits in some specific use case, some specific context, and some others are better performant in another one. So yeah.
And actually, this is one aspect we'll be addressing during the rollout of the project. So the analyze, deploy, and scale approach. So actually, we'll be able to recommend the best split between all data collection methods and how it can all integrate within the platform.
Okay, it's 5:31 here in Western Europe. So we're gonna close this webinar. Sorry again for this Zoom problem to share a demo. So we'll do a demo on our side. We'll record ourselves and we'll stick it to this webinar just for you to catch up with the platform. Thank you very much for your time and this interaction. That was pretty interesting for us as well. And yeah, have a good day, afternoon, morning, wherever you can be. Thanks a lot.